My name is David Follis, and I'm from the IBM Software Development Lab for WebSphere Application Server. This is a technical overview presentation on the JSR352 Java Batch standard and IBM solution based on JSR352. In this presentation, we'll cover three topics. First, we'll provide a brief overview of batch processing. We do this as a way to set context and provide some background on the evolution to batch processing using Java. That evolution led to the development of an open standard for Java batch processing, which was JSR352, the open standard specification for Java batch processing. In this section, we'll offer a general review of the standard. This will help you understand what the standard provides. What the standard does not provide can be added by vendors as JSR352 extensions, which IBM has developed as a way to offer additional value above and beyond what the standard itself requires. So get a cup of coffee and sit back as we take you through this presentation. Batch processing has been around a long time. The picture in the chart was from about the mid-1960s, but batch predated that by a fair amount. For example, punch cards as a way to hold data were used with mechanical computers in the late 1890s and the first half of the 20th century. Even though real-time and online processing is more widely known, the need to do data processing in bulk, which is another way of referring to batch, continues to this day. It's very unlikely it will ever go away. Some work is just better suited to doing in batches. What has changed is the approach. That's evolved over time as different technologies emerged. The two key areas of change in batch processing involve the storage medium used and the programming language employed. At first, it was punch cards or punch tape, and the programming language was Fortran or assembler. That gave way to magnetic disk, relational database programs, and languages such as COBOL. Today, the source of data for batch processing can be pretty much anything, and the programming language used is often Java. But change doesn't happen in a vacuum. Something creates a need to change. What's driving the change to Java for batch processing? We'll look at that next. We see three things behind the move to Java for batch processing. The first is a desire to modernize batch processing. This is not just a buzzword. By modernize, we mean engineering batch processing to take advantage of more modern technologies. Sometimes that's as simple as a new batch requirement coming up and a decision to write the new program in Java. Other times it involves incorporating a rules engine, such as IBM's Operational Decision Manager, to separate business decision logic from the batch program's processing logic. Whatever the trigger, the desire to modernize batch processing is becoming very common. The second thing is based on the availability of programming skills. Java programming skills are relatively common, while COBOL skills are becoming less common. Java is seen as a language of the future, so naturally Java will be considered for any batch modernization projects. The final thing is related to mainframe ZOS batch processing. On the mainframe, processors known as specialty engines are used to offload certain types of work. Specialty engines provide a financial incentive to use Java on the mainframe. Therefore, another motivation to use Java for batch processing is to move from COBOL to Java on the mainframe as a way to reduce general processor usage. A question that often comes up is this: can Java run as fast as compiled COBOL? The answer is yes, it can run comparably fast and times faster. Well, please note the asterisk and the note about how results vary. Performance testing and results are based on many factors, and the results you see may not be what we saw in the test lab. We're not promising performance results with this chart. Back to Java being comparable to compiled COBOL. How can that be? Java is an interpreted language, right? Java has what's called a just-in-time compiler, which compiles Java classes that are frequently used. Batch processing is iterative in nature, so Java batch programs are good candidates for code being just-in-time compiled. The just-in-time compiler, the JIT in shorthand, uses the latest developments in compiler technology. A lot of COBOL was last compiled many years ago with earlier compiler technology. Another thing to understand is that the System-Z processor chip has a lot of instructions that were designed to help the Java runtime operate faster. The JIT compiler knows about these instructions and uses them when it compiles the code. Again, COBOL compiled years or decades ago does not have this advantage. Java Batch has evolved over time. In the early days, Java Batch was mostly roll your own code based on the idea of launching a JVM, running the Java program, and then ending. The Java Batch code was almost all custom code, with only a little reuse of common routines. When vendor frameworks came into the picture, people started using them. They offered functions that made the Java programmer's job easier. And then a few years ago, an open standard project started. This standard, known as JSR352, is like other open standards. It allows the industry to settle around a common standard which promotes the development of reusable libraries and allows developers to focus on the business logic. That's where we are today, and that's what we'll talk about next. How open standards come about may seem mysterious, but it's really not. Before an open standard is created, different people work on a technical challenge, often independent of one another. At some point they realize others are working on the same problem, so they decide to come together and form a working group to study the problem to see if an open standard makes sense. This is what happened with Java Batch. IBM led that effort with the involvement of people from several other companies. After discussion and review, an open standard is published. For Java Batch, that open standard is known as JSR352. The initial release of this standard was in May of 2013. The standard documentation can be found at the URL shown on the chart. After the standard is published, vendors such as IBM build the standard into products. Vendors are free to provide extensions to the standard to provide additional value. That's what IBM has done with the JSR352 standard. Let's step back and look at a batch job from a very high level. This will help set the stage for our discussion of JSR352. We start with a batch job. A job represents all the work related to a given batch processing requirement. Jobs contain job steps. A step represents a portion of batch processing that takes place within the overall job. A job may contain one step or many steps. At a high level, a job step does three things. It reads in some data, it processes that data, and then it writes out the resulting data. For a batch job to start up and run, a function needs to be part of the runtime that listens for and understands the job submission request when it comes in. That means we need some way to describe the batch job so the job initiator function can understand what it's supposed to do. And we need some way to keep track of the batch jobs. This is needed because batch jobs may need to be restarted, and in that case we need to know where to pick up and continue the batch job. We offered this high-level overview because it helps us explain the JSR352 standard. We look at that next. This is the diagram found in the JSR352 documentation. It's not unique to JSR352. It's really just a generic representation of batch processing. The JSR352 documentation uses it, so we'll use it here as well. As we mentioned earlier, the job is the logical representation of the batch processing work to be done. A job step represents a portion of the work to be done within the job. A job may consist of one to many steps. A step reads in data. In JSR352 language, this is the item reader. It's an interface for the Java developer to implement that reads the data needed for the batch job. A step processes the data. This is known as the item processor. Again, this is an interface the Java developer implements that does the data processing for the batch job. A step writes the data. This is known as the item writer. This is also an interface to the Java code for the write pattern. Here's where things get interesting. The item writer may not be called for each record. The JSR352 runtime container calls the item writer when a chunk interval has been reached. A chunk is a set of data records, for example, every 100 records. Think of a chunk interval as a commit interval. The JSR352 standard defines the job operator as the interface to submit, monitor, and control jobs. The job specification language file is what describes the job details to the job operator and the JSR352 runtime environment. This is an XML file. We'll peek inside an example JSL file in a few charts. Finally, the job repository is the data store used to keep track of jobs. The JSR352 specification indicates a job repository is required, but does not spell out how it should be implemented. This is an area where vendors may provide extensions for additional value. We'll show you how IBM implemented the job repository later in this presentation. The chart we just showed looks like the Java batch programmer has a lot of work to do, but that's not the case. Most of what was on that diagram is functions supplied by the JSR352 runtime. This chart shows what the Java developer has to write. On the right side of the chart, we see the light yellow ovals. Those represent the Java code that implements the item reader, item processor, and item writer. That code sits behind the JSR352 interface for each and is invoked by JSR352 runtime as the batch job runs. A job specification language file is needed, so the Java developer needs to do this. Finally, the light yellow oval above the job operator box is shown as optional. It's optional based on whether a vendor has supplied a job submission function. IBM has. It's the REST interface to JSR352, and we'll look at that in more detail later in this presentation. The JSR352 standard describes two job step types, chunk and batchlet. Earlier we showed you the picture of the job step with the read, process, and write pattern. The JSR352 standard calls this the item reader, item processor, and item writer. That's the chunk step type. It's a very common way of doing batch processing. The other step type is known as batchlet. It's less structured than a chunk style setup. A batchlet is called by the JSR352 container. It runs, does whatever it's coded to do, and ends. It's useful for things that take time but are not iterative in nature. An example is a batchlet step that FTPs a large file. Batchlets are also useful for existing Java main programs you may have. They can be easily packaged as a batchlet and run within the JSR352 environment. A batch job may consist of either of these step types, or both. To illustrate the batchlet and chunk step types, we'll use one of the IBM sample programs as a backdrop for discussion. The sample is a two-step job based on an account balance model. The first step is called generate, and it's a batchlet step. It writes a number of account records to a file. A property on the step tells the Java code how many records to create. The second step is called add bonus, and it's a chunk step. It reads the account records created by the first step, adds a fixed integer amount to the balance, this is the bonus, and inserts the records into a relational database table. A job specification language file provides the JSR352 runtime with information about the job and its steps. We'll look at that in a moment. This sample is a little too simple to be real world, but it's useful in showing what a JSR352 batch program looks like. Let's now take a look at how this sample application is packaged. We start with the Java developer. The application is written and packaged as a WAR file. The WAR file is what gets deployed into the Liberty Profile runtime. At this point, we should pause and let you know that we're not going to be going into the details of developing a JSR352 batch program. It's an important topic, no doubt, but these details are beyond what we're trying to do here in this technical overview. For now, just imagine the Java developer has done all the right things and an application WAR file is produced. The contents of the WAR file look like this. The first step, which was the batchlet step, is packaged as the class file indicated here. The second step, which was the chunk step, must implement an item reader, item processor, and item writer. That's what the JSR352 standard calls for. Those three class files are shown here. The job specification language file is packaged with the WAR file under the meta-inf directory. When packaged as a WAR file, this deploys into the Liberty Profile drop-ins directory, just as any other application would be deployed. Or if you wish, you may deploy it somewhere else and point to it with an application element. The key point is that from a Liberty Profile deployment point of view, the Java batch program is just like any other application. Now let's take a look at the job specification language file, which is often referred to as the JSL file. We'll do this in two parts. If we put everything on one chart, the type would be too small to read. These are the job properties. Job properties are values that are used by the Java code in the job steps to control how the programs run. Here we see properties such as the number of records to write, the chunk size to use, and information about how the database can be reached. The values you see here are the default values. These can be overridden at job submission time. The first job step is defined as a batchlet. You can see the Java class is specified as well. This class file was seen in the chart we showed you on the application packaging. This step has one property. It tells the Java program how many account records to write into the file. The value is inherited from the job properties above. That's the first part of the JSL. Let's take a look at the second part now. Here's the second part of the JSL file. This step is defined as a chunk step. The step has a property that indicates the chunk size, which is the number of records to process before calling the item writer to write the records into the database. Since the step is defined as a chunk type, it must implement an item reader, item processor, and item writer. Those are the three class files you see here. The processor has a property for the bonus to add to each account's balance. The writer has two properties related to how to reach the database and what table to use. Put the two charts together and you have the full JSL file. The JSL file tells the JSR352 runtime what Java class files to use and other information about how to operate. The chunk step model iterates through records, and if updates are taking place, you'll want to commit at checkpoint intervals rather than one big commit at the very end. The JSR352 specification provides for this. Imagine a set of data records a batch job is going to operate on. You specify the item count in the JSL for the chunk step. Here we're showing a checkpoint interval of every 5 records. As the batch container iterates by invoking the item reader and item processor, it keeps count of the number of records processed. When the item count is reached, it processes a commit, and the updates are written out by the item writer. This item count value may be externalized as a property, which may be set in the JSL, or passed in as an override variable at the time of job submission. Essentially what takes place is the container wraps a Java transaction around its processing. It keeps track of where it is in the item count iteration, and when the checkpoint is reached, it commits the transaction, which results in the updated records being written out. The container persists the value of the last good checkpoint interval reached. If the job step is restarted, the container will read in the last good value and start from there. If the job step fails at some point before a checkpoint interval, the container will process a rollback to the last good checkpoint. The value of this is that it's all managed by the container. Your code does not need to get involved in the looping or keeping count of the loops or starting a transaction or committing the transaction. That's all the responsibility of the JSR352 container. The next topic is on processing splits and flows. Imagine a typical job that processes a sequence of 5 steps executed sequentially, one after another until all 5 are complete. That's a fairly common pattern. With JSR352, you may arrange your job steps into splits and flows. This allows you to process some job steps in parallel and organize some job steps into logical groupings called flows. Here's the same 5-step job organized into a split with 2 flows defined. You define the splits and flows with XML in the job specification language document. Splits will process on separate threads in the JVM. You have conditional processing control just as you do with simple sequential patterns. The value of this is that it gives you flexibility to design your job step execution. If you have the ability to execute some job steps concurrently, you may do that. Now let's look at step partitioning. This is a way to execute concurrently within a job step. Take, for example, a hypothetical job step. Imagine you know the layout of the data for that job step, and you know it lends itself to parallel processing based on ranges of the data. The partitioning of the data is really up to code you write. There are several ways to approach this, from specified data record ranges to having your code calculate the ranges based on the number of partitions you wish to run. Your code does the data partitioning, then the container will dispatch the partitions to separate execution threads in the JVM. When all the partitions complete, then the job step ends. This provides a way to execute a job step in parallel when the nature of the step lends itself to partitioning the data and running separately. Finally, let's talk about listeners. Think of these as exits where your code gets control when a certain event takes place in the Java batch job processing. For example, one listener is the job listener. This is an interface, and your listener code runs behind this interface. The container calls this listener at the start of the job, at the end of the job, and if an exception is thrown during job execution processing. Another listener is the step listener. This gets control at the beginning and end of each step, and if a step execution exception is thrown. The chunk listener gets control at the beginning and end of each chunk, and if an exception is thrown. And the other listeners, item read, item process, item write, skip, and retry. For all the listeners, the concept is the same. Your listener code resides behind the interface. If a listener is registered, then that listener code is called at the specified time. When complete, the listener code returns control to the container. That's the basics of JSR352. But the standard doesn't say much about operational things. That's where IBM has provided quite a few extensions to the standard. We'll look at those next. IBM's JSR352 implementation is built to run in Liberty Profile. All operating system platforms supported by Liberty Profile support running JSR352. Liberty Profile is IBM's lightweight, composable, and dynamic server runtime environment. Liberty provides a Java virtual machine that stays up and active as long as the Liberty profile server itself is active. That means you can start and run hundreds or thousands of Java batch jobs without having to start and stop the JVM each time. As we mentioned, the JSR352 standard is focused on the programming aspects of Java batch. IBM has extended the standard with quite a few operational extensions. We're going to cover what these extensions are for the rest of this presentation. The JSR352 standard calls for a job repository to be available, but the standard does not spell out details about how it should be implemented. IBM has provided 3 options for the job repository based on what you need. They are an in-memory job repository, which is very easy to set up since it requires virtually no setup. It just works. This is great for development and test, but it won't survive a server restart, so it's not appropriate for environments that require that level of persistence. A file-based Derby job repository. This will survive a server restart and has the benefit of being relatively easy to set up. This is good for more robust test environments. A relational database product job repository, such as IBM DB2. The table creation for the job repository is automatic, and it's relatively easy to drop the tables and start with a fresh set if you want. Also, you can start with Derby, for example, and then later drop those tables and recreate in DB2 when you move to a production environment. The JSR352 standard calls for a job operator to be available, and it details the interface requirements of the job operator. But it doesn't spell out any details about how external or remote clients would access the job operator. To address this, IBM has created a REST interface to the job operator function of JSR352. This provides a way to remotely submit, monitor, and control Java batch jobs running in the IBM JSR352 runtime. The REST interface provides a security layer as well. The REST interface provides a point for authenticating users seeking to use the interface, and it provides a role-based mechanism for granting access to the functions of the REST interface. The interface supports the use of JavaScript object notation, or JSON for short, to carry the specifics of the job submission. This includes such things as the batch job application name and any job properties you wish to pass in. The REST interface provides a way to remotely submit jobs and control them. That's important because it provides a way to integrate with things such as external schedulers. Those schedulers may or may not understand the IBM Java Batch REST interface, so a command line client is also provided. On the previous chart, we illustrated the REST interface. Now let's look at a command line utility IBM provides to drive that REST interface. The utility is called Batch Manager. It's a Java client that will take command line input and format it into REST JSON and send it to the REST interface. To integrate with an external scheduler, you could write a shell script that invokes this Batch Manager client. The shell script would be invoked by the scheduler. A wait parameter tells the Batch Manager to stay active until the Java batch job in the JSR352 runtime completes. When the job completes, the Batch Manager client can retrieve the job log information and retrieve the entire log if desired. For ZOS, there's also a native command line utility. This doesn't use the REST interface. This uses WebSphere Optimized Local Adapters, or WOLA, to go cross-memory into the Liberty Profile server. This client's not a Java client, so there's no need to start and stop a JVM each time you invoke it. It's cross-memory, which means the latency is very low. Because it's cross-memory, there's no SSL and SSL certificates to manage. The same authorization model applies, so you can control what access a user of this client has when using the JSR352 job operator interface. Now let's talk about another IBM extension to the JSR352 standard. This is called multi-JVM support. It provides a way to separate the roles, with one server JVM acting as the dispatcher and other server JVMs acting as the Java batch runtime endpoints. The same job submission clients we just discussed can be used to interact with a JVM acting as a dispatcher. When configured, the server acting as the dispatcher will take the job submission request and put it on a JMS queue, which may be either a service integration bus queue or an MQ queue. Then servers designated as Java batch endpoints listen on the queue and pick up those job submission messages intended for it. We show how that's done on the next chart. This design provides a way to separate duties and spread the job execution across servers. It provides a way to run batch jobs by server. It provides a way to submit batch jobs and have them queue up and wait until the intended execution endpoint is started later in the day. In short, this function provides you with a great deal of operational flexibility to design and operate your JSR352 Java batch runtime. You may wonder how a batch endpoint knows what job submission messages to pick up. It's based on properties you code in the server XML for the endpoint server. These properties are called message selectors, and they tell the endpoint server what messages to look for and pick up. For example, here's a message selector property that will look for and pick up any messages where the application name is batch job A. Here's a message selector property that looks for either batch job A or batch job B. This is how you deploy multiple batch applications in the same server and have the job submission messages for each picked up. Here's an example showing how your own custom properties can be used on the message selector. This is showing a message selector looking for the application name batch job A and the custom property called myProperty with a value of myValue. In summary, this function allows you to submit jobs even if the endpoint server isn't running. When that endpoint server starts, it will pick up the messages from the queue and run the batch job. This also allows you to target job execution to specific servers based on the message selectors you code in the server. And this is not limited to a single system or platform. You may have dispatcher or endpoints on different hardware and have it span different operating systems if you wish. This is a distributed architecture here. Now let's look at job logging. When configured, the IBM JSR352 job logging function will separate job logs by batch application, date, job instance, and job execution. This provides a way to keep job logs organized for later retrieval. Speaking of retrieval, the job logs for a job can be retrieved through the REST interface or the Batch Manager command line client. This can be used to remotely retrieve the job log for archival if desired. Let's take a peek at what the Liberty Profile server configuration file looks like for JSR352 support. There's a few updates to enable the support. The Batch 1.0 feature enables the core JSR352 support. If you want to use the REST interface, enable job logging, or the multi-JVM support, you code the Batch Management 1.0 feature. The batch persistent element is used to indicate where the job repository is located. We're leaving out some of the finer details because the chart would get too busy if we included them. What we're not showing is the standard configuration elements for JDBC, and if the multi-JVM support is used, the configuration elements for JMS. Other documentation provides those details. And here's the overall summary. Way back when, we had the early days of batch processing with punch cards and old computers. Over time, batch processing evolved with a push recently to modernization, Java and the JSR352 standard for Java Batch. The JSR352 specification defines a standard set of interfaces for Java Batch processing. IBM has implemented this to run on Liberty Profile, which runs on many different operating system platforms. IBM has added extensions around the standard, which includes several ways to configure a job repository, job logging, a REST interface for remote job submission, a command line client which is useful for external scheduler integration, on ZOS a native command line client, and the multi-JVM support we just discussed. And that's the IBM JSR352 Java Batch story.